And we should be live. I'm just testing my levels here. And in the live chat, we should have everything going. Let me just check. Perfect. Morning, everybody. I should be coming through loud and clear. If someone just wants to mention in the comment section there, that would be great. But I will continue to talk. So welcome everybody to our special live stream for Arduino Day. You're all very welcome. So Arduino Day is a worldwide celebration of all things Arduino. Lots of people are posting on social media about their experiences and their different projects. There's going to be an official Arduino live stream later on if you want to tune in. I think it's 3 o'clock our time from that. But I guess before we start, if you're new and you haven't heard about ourselves before, we are TOG Hackerspace. We have a physical presence in Blackpits in Dublin. We are around 100 plus members organisation who like to come together and make things, electronics, laser cutting, 3D printing, brewing, crafting, all sorts of different activities. We just love to get into and build things for the fun of it. So we have about 500 square meters there, unfortunately going unused due to this crazy global pandemic that we're in. But when restrictions allow, we hope to jump back in and open up and have you all in to see us. So our first speaker to kick off today's event is going to be Declan. He's going to be bringing us through getting started with Arduino. For all of you new people out there who want to kind of dip your toe into hobbyist electronics, you'll find it's a great platform and a lot of fun. So let me just change my screen here and I will queue up Declan.
Hello everyone, can you hear me okay?
Yeah, so they can hear you okay there, Declan. I've turned on your audio. And now I'm going to remove my face from the screen and let you kick on.
Hello everyone, thanks for joining us on Saturday. And I suppose this is something I'm really happy to talk about. When I joined TOG, it was one of the first things I got interested in. And, electronics is something that anyone can learn. It's something anyone can get involved in at whatever level. And it's just really satisfying to write some code, hook up a few wires and actually get something working. And really the easiest way to do this is the Arduino, but it's also an easy way, as you'll see throughout this series of talks. It's also a really powerful tool. So if you're curious about making it all, I'd really suggest just checking this out. So I'm going to talk briefly about why this isn't a computer and why that's important. So a computer is something that would have an operating system. So you might think of Linux or Windows 10. Computers would tend to be bigger and tend to be used for multiple things. They have things like web browsers or, word processors. But an example would be your Dell laptop or a Raspberry Pi. A microcontroller has its own it's not an operating system, it's called firmware. And it's just its own special instructions. They're designed for specialized tasks rather than general tasks. And, example would be a PIC, an Arduino, or a ESP board. Now, Arduino is a bit more than a microcontroller. I'll get to that in a second. So this is one example of a microcontroller. It's your typical microchip. And basically, these have been around for a long time. They're probably in every single piece of electronics you have, in your radio, in your microwave, in your washing machine. And they're great for a factory to install in a finished product. They're not so great if you want to tinker with them. So this will work, but you need a special device to program it. You need a crystal for timing. You need, you need lots of stuff, either solder onto it or put on a breadboard. So that isn't very accessible. And this is where Arduino made a really good innovation. So this is an Arduino Uno. It's probably the best one to start with because it's kind of a good all-rounder. And this does something differently. As you can see, it has a chip like the one we had before on the board. But it also has a USB port, and that's used for two things. You can use the USB to power it, but you can also use it to very easily connect it to a computer and send it instructions. It also then, if you don't want to power it by USB, you can also power it from that barrel jack, and you can even power it through some of the input pins there, which we'll get to later. So the Arduino takes what is a bit of a specialized thing and makes it so you just plug it in and use it. And that's something that I think is really important, really powerful, and it's something that we can do a lot with. Okay. So one of the cool things about Arduino is its open hardware, and this is something I'm really passionate about. Open hardware means that all of the plans are online. Now, maybe some other companies put technical manuals online, but these are open source, which means anyone can look at them, anyone can modify them, anyone can contribute to actually writing them. This has benefits because, first of all, if you're thinking, will the Arduino work for me? Well, you can go in a lot of detail and you can actually look at it and say, okay, yes, it will, no, it won't. It also means if you want to adapt it, you can use it, you can make your own with a specific feature, or you can make a cheaper version of your own. And it's also very easy to do things on top of the Arduino. So one of the things is this company called ATtiny, and they make kind of Teensy, which is like an Arduino board, but it's a bit more advanced. And you buy it, they can be a bit expensive, but the guy who makes those also contributes to the Arduino project. And you get a company like Adafruit who've built their own boards, they build their own components, but they also contribute libraries to the Arduino project. So it just means it's open, it's more expansible, and also then people actually volunteer to help write this code. So it's a community piece of hardware. And I think when we talk about the Arduino, it's great just to get hardware, but I think it's also great because it is a community. And I think that element of this stuff needs to be talked about a bit more. So if there are any budding hardware engineers, I'm sure there's ways to contribute. So just as an example, and don't worry, you don't need to know everything on this, but this is just an example of one of the schematics of the Arduino that's widely available. And all you need to see is, look, it takes a microcontroller and it puts everything around the microcontroller that you need to use it easily. That's kind of the point of this slide. So to write software to the Arduino, you use something called the Arduino IDE, and it's Integrated Development Environment. And there's basically three ways to do it. They actually have a web version, which is very handy, especially if you're doing like Chromecasts or if you can't install stuff. They've also got Android and iPhone apps, but the main one is just to download the software and run it. That's how I would recommend doing it. And there's lots of things there. You just plug in your board and you run. The first thing you run is you go into the examples menu, run blink. And all it does is it blinks an LED on the board. And you don't need to do any code, and that just says everything's working. I'm not going to take you through exactly how to do it because there's so many of these on YouTube, so many tutorials. I will say some of the things to check is, have you got your board and your COM port? If you go into the tools menu, that can sometimes go wrong. But there's lots of support online for how to fix it, and just don't, tinker with it a bit. And once you get one sketch running, you'll be able to run them all. Arduino calls things sketches, and that is just a text file with instructions for the board. There's lots of examples available online in the examples folder, and also just, if you Google how to do this in Arduino, you'll find it. And really, don't be intimidated by the code. It's just grabbing two examples and mashing them up together. It's very logical. If you have coded before, it'll be no problem. If you haven't coded before, there are lots of books, tutorials, everything is available. And also, we'll get to the end, but, get involved in TOG. There's plenty of people happy to give you a bit of guidance on it. So the Arduino board, one of the things that's really cool is it has a lot of input plugs. And basically what that means is you can very easily wire something up with a little jumper lead. So I'm not going to cover it all. It has some very advanced connection options, and it, you can do quite a lot, but there's sort of three main things. So just below the power on the top left, there's a row of plugs, and basically these are power. So you can get 3 volts or 3.2 volts, and also a ground pin. So if you're wiring something up to a circuit like this, that's how you do it. And sometimes people just use an Arduino to give your project 5 volts of power, which it is quite good at, but you can do more with it as well. Below that are the analog pins, and I'll just get what analog is later. And on the right, we have digital pins, so they can be controlled. They've got, some of them are PWM, and we'll cover that. So what is analog and digital? Basically, if you think of your typical wave of a signal, like a radio wave that you'd see on those visualizations, I mean, that's a digital signal. It's just a waveform. It goes up and down. And that can represent a voltage, that can represent temperature, that can represent movement. And it means that, the Arduino takes a reading of it and says, where is this between these two values? So if you want to have a motion sensor and say, okay, well, if it's a little motion, do this, and if it's a big motion, do that, that's what you'd use for analog. Digital is just 1 and 0. And what that means is the pin either gives 5 volts or it gives nothing. So that's digital communication. Now, to confuse it further, there's something called pulse width modulation, PWM. And what that means is it powers it on and off very quickly at a certain percentage, and that's used to control things like dimming LEDs or some of the motors. So they're the 3 kind of main categories. And again, there's lots of tutorials on these. There's lots of things you can do, but you need these to know whether you're dealing with something that's analog or digital. Okay, so LEDs, probably the first component you're going to connect to an Arduino, light emitting diodes, but basically it's just a little light. You can get them on their own, which again, 2 or 3 of them, just make sure you know what resistance you need, and then you get a strip of lights. And again, some of these strips are very simple, you just power them on. Some of them are complicated, so you can get things like neopixels where each light is individually addressable. And some of the things you can do with strips are quite interesting. Like one of the things I saw was kind of a football game where the strip would light up based on whether you threw the ball in or not. So that would use sensors and strips. So these are quite good. They're quite usable, and you can do some very interesting things. A lot of people use them for props and different things like that as well. So just keep that in mind. And obviously, some of the strips require extra power, some of them don't. So just keep an eye on that. How are they going to be powered? Now, this is sensors. So I'm not going to go into these in too much detail, but like there's things like heat and light sensors, and there's motion sensors. So all of these are connected, some of them digitally, some of them through analog. And again, if you look in the examples folder, it probably has the code you need to use a sensor already. So it is quite simple. It's quite easy to do. If you look at something like a temperature sensor, again, it depends which one you get, and it's always good to look at the documentation that comes with it so you know where these things can be used. But yeah, there's lots of different ones out there. And then, of course, you can light up based on what the sensors do. Okay, so these are motors. And we'll go from maybe the simplest, which is a DC motor, which is just you turn it on or you turn it off and it spins or it doesn't spin. So these are quite good and quite handy for, a simple kind of car. If you want to get a bit fancier, then you have a servo. And what that is, it's a motor that's controlled digitally, and you can tell it to turn at a certain angle. So servos, they make the noise, and they're pretty handy for, say, robotics, for moving arms, animatronics, that kind of thing. Stepper motor is a bit more complicated. That you actually tell it how many steps to turn. So stepper motors just give you a bit more granular control, and like they'd be used in things like moving around a 3D printer, but you can use them. A lot of these are interchangeable. So yeah, it's kind of good to think about, look through what kind of motor you want, whether it's supported by the Arduino. Some of them maybe require more than 5 volts, and you might need an extra power source for them. But yeah, there's lots of motors out there. So I'm going to talk about 2 projects just to finish up. And I suppose what I want to get across is to think of some, be creative with what you're making, and, make your ideas happen. On the right, you can see a kind of a hedgehog, and then in the middle, there's kind of a robot car, and the robot car has a trolley with LEDs. Why wouldn't a robotic hedgehog pull around his own lighting system? This was something I did at Science Hack Day, by the way, which is an event hopefully to come back soon when time allows, where we just spent a weekend hacking away on things. And you can get lots of robot cars and do things like that, but that is all powered by an Arduino. Now, this video won't play, unfortunately, but I'd suggest you look it up. Everyone's heard this Wellerman sea shanty, but that's this performed by servo motors. So they make slightly different notes when they turn to different things. So someone actually performed. So whatever you have in mind, just make something that's silly, brighten people's day, have a bit of fun. And the main thing about this is there's a lot of support out there. So we'll come to questions now, but just to say, we have programming nights in Tog. We have an active Discord server. We have an email address, and just ask your questions, get involved, and we'll see if we can do, because there's a lot of support out there for this. And I really would encourage you to just try and make something with the Arduino. It's a great platform. So I think that's it for me. Have we any questions?
Thanks very much, Declan. Just let me put myself back on the screen. I think I am on there now. Perfect. So, Declan, I have the first question in here is, so someone watching along the stream is a bit worried that they're not a coder.
Yeah. So a lot of the coding is very simple, and it is literally copying an example, pasting it in, and just running it. And a lot of them are very well documented, so it'll have a little comment. It is probably worth, going through the basics of this, but don't be intimidated by the code at all, because, especially for simpler projects, someone's probably already done it, and you can just reuse their code and maybe change a few numbers. But I definitely wouldn't, I did learn to code years ago, but I'm not a coder in my daily life, and I know just enough to get by, but I find it very easy to code in Arduino. And there's lots of support out there. So it's not something I'd say you pick up straight away, but it is very achievable. And you can get good results with a half hour of tinkering around with it.
Okay. And the next question I have here is, someone wants to know your favorite project you've made using an Arduino.
Weirdly enough, I couldn't embed the video of it, but the project I made was, I made a model church, and I put a bell in it on a servo motor, and it was remote controlled. So this was my Christmas desk for work. And I was surprised it worked. It really surprised me that I got it to work. And I was very happy with that. Just think of little things like that can be very creative,
Yeah. And then I have here a final question. So we hear about IoT stuff all the time now. Mm-hmm. Can you get Arduinos on the internet?
Yes, you can. So I suppose there's a few ways to do it. So one of the things is you can control it with something like a Raspberry Pi, and that's what one of the more advanced connection I/O options is, to send signals from the Pi, which would be online. You can also get a Wi-Fi shield or an Ethernet shield, and I didn't really get into this, but shields are just they're add-on boards. It's a bit like Lego. It's on the top of the Arduino to add some functionality to it. So yeah, there's lots of ways to get it on the internet, and it's better that you make your own IoT than some of these companies having your data. So definitely give it a go.
Very good. All right, Declan, I think that's all the questions we have in here. Thanks for coming along this morning and giving us an introduction into a great little platform.
Okay, thanks very much, everyone. Hope you enjoy the rest of the day.
Thanks. So, thanks again, Declan, for giving us that great start. I am going to switch you all to a slideshow of various pictures that I found on my Google Photos that had Arduinos in it. I just put a search for electronics and picked the random photos. So I'm going to switch you all to that while I set up our next speaker's video call. So hang on, we'll be back in 1 minute. And we are back. I hope you all enjoyed photos from years gone by of various states of electronic projects that I have been involved with. So next up here we have Gary, who's going to be talking about all his temperature sensing projects. And also, for those of you who don't know, Gary runs our regular electronics night that takes place when we aren't restricted from using the space. So Gary, take it away there.
Yeah, thanks, Jeff. So, every in normal times, every second Monday, we have electronics night in Tog, 7 to half 9 or thereabouts, and you can come in, know everything, know whether you know everything or nothing. It's a theme night. You can, if you want to do some of this stuff, electronics / Arduino, anything else. We've lots of stuff in there. If you're a beginner, don't know how to get started, come in and see us. It's open door. So, kind of just following on from Declan, I suppose a real application that I've been doing over the last year, I needed to measure some temperatures for 2 projects I've been doing at home. One is I built a solar heat collector to heat the house. It's on the wall, sun shines on it, gets hot. I draw hot air out of it, and I through a heat exchanger, and I put it through my underfloor pipes. And I need to measure temperatures and that, obviously, because I have an Arduino running the whole show. And then a second project I was doing more recently was I wanted to monitor the temperatures in my water cylinder. So also used an Arduino and 6 of these temperature sensors. So you may or may not know, a very simple component to do temperature measurement is called a thermistor, which is really it's a amalgamation of thermal resistor. And a resistor just has the property of electrical resistance, and these particular ones, that resistance changes with temperature. So you can, if you monitor that resistance, you can correlate it to temperature and say, and I don't know if you can just about see the writing on some of these, NTC, and some are called PTC, positive temperature coefficient, negative temperature coefficient. Some of them, the resistance goes down when they get hotter. Some of them, the resistance goes up when they get hotter. You can measure that with your Arduino and work out, okay, I know my thing is too hot or too cold, and turn on or off fans, pumps, whatever you want to do, or just put it up on a display. So they're traditional thermistors, and they just change resistance, and that's fine. They work. And if you want to connect them up to an Arduino, there's a little Uno. You can simply connect this thing up, give it power and ground off your Arduino, and it's just a voltage divider. It's a fixed resistor, and this thermistor is a variable resistor that varies with temperature, and you can just pick off the midpoint, feed it into an analog input, and you will get a varying voltage, and you can do what you want in your code with that voltage. So that's nice. That all works, but it doesn't give you it doesn't tell you the thing you're measuring is 10 degrees or 20 degrees or whatever, or -5. It gives you a voltage, and you have to work out, well, I know when it's 1 volt, that really means 10 degrees. You have to do a bit of calculation. So there's kind of nicer ways to measure temperature. You can get devices that actually tell you their temperature in degrees or Fahrenheit if you want. So it'll actually spit out, 10.1 degrees directly, digitally, without you having to work out resistors and voltage ratios and all this. And you can also feed them into your Arduino. So the one I've been using for the last year, it's just a little thing. It's a little 3-legged thing made by Dallas Semiconductor originally. They've been taken over by Maxim. So you'll see them referred to as DS, Dallas Semiconductor 18B20. This is just the model number. If you look up 18B20 temperature sensor, you'll find these all over the internet. And this is a little 3-legged thing. That's kind of very blown up picture. In actual fact, the little plastic case that this thing is in is there is in relation to a coin. These are tiny little things that would fit in the tips of your fingers. Now, if you go to kind of Maxim's website, here we go, DS18B20, it's a programmable resolution, 1-wire digital thermometer, very fancy. Here's the thing here, accuracy, how accurate it is, 0.5 degrees centigrade. Depending on what you're doing, that could be brilliant or it could be terrible. You'll know from your own application. The interface, it's called OneWire, and I'll talk about that in a minute. It's probably a bit of marketing taken advantage. I'll tell you why. But if you look inside this thing, there's a block diagram over here, and here it is. For a little 3-pin package, and here's those 3 external legs: ground, voltage, and data, the data output of 3 legs. There's a lot in there. There's a little power circuit. There's some ROM, some logic in there. There's the actual temperature sensor itself. And then you have all these registers and configuration register stuff for a little 3-legged thing. There's an awful lot going on in there. Casually to look at it, if you know electronic components, you might think, oh, that's just a transistor. But there's actually a lot in there. So when you buy them, you could buy them like that transistor, little thing, raw. But what I did was, you could buy them ready-made. That thing is inside here in this sleeve. There's a nice stainless steel end on it. It's heat shrinked on. There's some glue under there. And there's about a 1 meter long cord with the 3 wires sticking out. So this thing is fairly waterproof. So it's when you buy them like this, it's ready to go. You just strip the ends of those wires, stick them into your Arduino, and you know that's it. Apart from one resistor, a pull-up resistor, it's called. And these are only, like on your typical Chinese websites, they're €1, $1, £1, you know, that kind of money. They're ultra cheap. You could buy a thermistor probably for 10 cents, but again, you solder wires onto it, try to put it in heat shrink, and then you've got to do something with the code because it doesn't actually give you a temperature output, it just gives you resistance. You can buy this thing for €1 and it's done. And that's what I did. I bought 10 of them in one batch, and then I bought, I think, 6 in another. So just quickly, if you look at some of the specs of these things, it measures temperatures from -55 to +125. It has a 0.5 plus or minus 0.5% accuracy from -10 to 85, which is most normal range of weather or indoors, anything you'd be measuring in your garden, greenhouse, heating, and so on. Little thing here, there's 3 wires on it, as you see. There's a little trick. If you only have a 2-wire cable and you wanted to use one of these, there's a little trick you can do to send the power and the signal down the same line. And they call it parasitic power mode. I didn't have to use it because I was just running in a cable anyway. And all I used was a bit of Cat6 cable. So that's a little trick if you've only got 2 wires available. And every one of these devices, every single one you buy has a unique 8-byte code, like a MAC address on your laptop or some internet device. Buried inside this thing in the ROM is its own unique little code. So you can address or read every one of these individually, even though they're all on the same line. So one little trick, as I said, if you notice from the start, they call these programmable resolution 1-wire digital thermometer. 1 wire, well, there's 3 wires. It's a bit of a taking a liberty a bit. I mean, the 1 wire is the signal wire. The thing still needs power. You know, it's really a 3-wire device. But as I say, you can get away with 2 with a little trick. So it's a bit of a misnomer to call it a 1-wire. But anyway, it's very simple. Power-wise, if you know Arduino, is it 3.3, is it 5.5? These things can work from +3 to +5.5. So whether you're using 3.3 volts or 5, it's fine. There's your accuracy again. It's plus or minus 0.5 of a degree for most normal temperatures, if I could put it that way. And in terms of kind of current consumption, typically milliamp is all these things use, very low. You could battery power these or solar panel power them, small solar panel or something. Very low power. There is some EEPROM in there, some memory, and some of that memory, a bit like the memory card in your phone or your laptop or your Raspberry Pi, you can only write to it so many times, and it retains data for only a certain time. But it's like 50,000 writes and 10-year data retention. So you're not writing to these back and forward all the time. You're just reading from them. What's your temperature? What's your temperature? What's your temperature? You can write to them to set configuration. I want this resolution. I want this setting, but you typically only do that once. Resolutions, you can tell it, give me 9-bit resolution, 10-bit, 11-bit, 12-bit. The more resolution, by resolution I mean, are you going to tell me it's 10 degrees or 10.1 degrees or 10.05 degrees or 10.008 degrees? How many decimal points of accuracy are you going to tell me? The maximum is 12 bits. I think that equates to 3 decimal places. So in theory, you could have the thing telling you it's 10.125 degrees. The more accuracy you ask for, the slower the conversion. But still at the greatest accuracy, it's 750 milliseconds, which is less than a second. One thing to be aware of, resolution and accuracy are not the same thing. If the thing has an accuracy of plus or minus 0.5 degree, well, telling you that it's 10.005, is it really 10.005? Maybe you could read a single sensor, and if it's saying it's 10.005 now, and in a minute's time it's telling you it's 10.015, well, you could say, well, it's gone up, right? It's probably true. The temperature's truly gone up, but is it really accurate reading? Probably not. Just bear that in mind. As I say, resolution and accuracy are not the same thing. So in Arduino, you don't have to write any serious code for this. There's libraries already written. There's a library called OneWire, which is for that one-wire communications protocol, and there's another library for these temperature sensors called Dallas temperature, and you can just import those or include them in your Arduino code. You don't have to write those, and they give you all the functions and methods you need to talk to this thing, to ask it what's your address, set your resolution to 10 bits, tell me your temperature. These libraries do all that for you. You just have to call the functions and methods. So as I said, each of these devices has an address buried inside, and it's an 8-byte address, and one of the functions in those libraries is to poll all the devices on the network and tell me your address. And here's the way they come back, 28F3 BE, whatever, and everyone just has a unique address. So the libraries will do that for you. One thing I did, since I've mentioned the accuracy and the resolution of these, I bought 10 of them in one go from AliExpress, on the thinking that, well, all 10 of them are probably going to be from the same manufacturing batch. They'll probably all be, hopefully, much the same. So what I did was I got all 10 of them, got their addresses using the little library, and I said, well, are they all the same? And they're not all the same. If you put them all in the same thing, and I'll show you now, I just used a big mug of hot water, and I just read the temperatures constantly as it cooled down, and I pulled all the data into a table. What I found was there was a difference of, a degree, more than a degree. And what I did was I picked one of them and said, okay, your baseline, and I'm going to characterize every one compared to you. And so I picked one of them and I called it 0. And all of the others, I kind of averaged out all the readings and said, you know what, that one there, you're like typically minus 0.005 degree different than baseline. You're up top here, you're typically minus 1.41 degrees. I just did a big spreadsheet and played around with the values. How much of an offset do I need to add on average to equal the baseline? And that's what I did on it. You do that once, and I incorporated that into my code because I'm in some cases I'm measuring very small temperature differentials. So here's me normalizing my sensors. Big mug of hot water, all 10 of them together, and I'm just reading the values, constantly read, and spitting the values out into a serial monitor in the Arduino software. This is all part of the Arduino IDE. And I just grabbed all that and pasted it into a spreadsheet. There they all are in the water, just as the water's cooling down. And I just kept them moving so there was no hot spots in the water and so on. So how you connect these up to an Arduino, there's a single one. You give a power, you give a ground, 5 or 3.3, and you get a single data line out pin 2 into any Arduino digital input. And you've got one resistor, it's called a pull-up resistor, something between 1 and 10K, it doesn't really matter. 4.7 they've used here. And that's it. If you connect that little thing up to your Arduino like that, simple program, pull in those 2 libraries, you can straight away start reading what's your MAC address or your whatever you call it, your device address, what's your temperature, set this resolution, and away it goes. Very simple. There's just an example of 6 of them on my hot water cylinder. I just have all 6 from top to bottom on my cylinder. Here's all 6 lines coming in, all 6 power in red, all 6 grounds in black, and all 6 signal in the middle. 1 resistor, and the serial data from all. So you don't need 6 separate digital inputs. 1 is enough, and the library can pull that network, and even though they're all talking on the same yellow wire, it can read them all individually because it knows, because it's asked them their address when you run the code for the first time. So when I pull that raw data into Arduino, you can do what you want with it then, display, truncate it to no decimal places, round it, do what you want with it, normalize it using those offsets. And here's a kind of a mock-up of my hot water cylinder top to bottom. The second project I'm playing around with. I'm trying to get a nice graphic that animates, I guess the hottest would be red, orange, yellow, down to blue being the coldest. So I'm trying to animate these colors at the moment based on the temperatures. So that's really the 2 projects I've been working on using these Dallas or Maxim, as they are now, 1-wire sensors. So they're a nice little sensor if you want to measure some temperatures. I'd really recommend them. If you need any help, give me a shout through Tog, or hopefully we get open again on a Monday night. That's me. Thanks a lot.
Thanks very much, Gary. Just let me stick myself on screen here and put you nice and big so everybody can see you. So I guess the first question that really came in during the last talk is about does Tog meet up for an Arduino group, or do we meet up about electronics?
Yeah.
Do you want to briefly talk about that?
Yeah. So, as was said at the beginning, what Tog is, we're a group of makers. We make and tinker and hack with anything and everything. And electronics is just one of them. So we have theme nights. In normal times, you'll see them in our calendar. Electronics is Monday night. It's not a class. It's not a workshop. You don't have to know anything. All you need to bring is some curiosity, interest. Just come in. If you don't know anything, just come in and see what's going on. We're open from typically 7 to 9:30. You can pop in. You don't have to stay the whole night. You can stay the whole night wherever you want. Bring something in. If you want to get started with something, Arduino is great for both code and electronics. Very simple. We'd say to get Blink working, as Declan has said earlier, and then you can start connecting up a few simple things, external LEDs, one of these temperature sensors, start spitting out a few values to the serial port, see them on your screen, and there's so much you can do. But come in if you're interested. Monday evenings when we get going again, definitely. All welcome.
Okay, and our first question here coming in on the chat line is the sensor waterproof enough to be stuck in a fish tank? Submerged water.
I'm as raw, definitely not. The thing is just a little transistor. But if you buy them like that from AliExpress, being hackers as we are, the first thing I did was cut one open to see what's inside. And that's a little stainless steel piece of tubing. It's blank at one end. The thing is in there. It seems to be either epoxy or hot melt glue or something. and then it's heat shrink over it. And I had them in that thing of water, albeit for maybe no more than half an hour. They all still worked. On my solar system, one has been in my panel for a year now, and one is outside the panel, like in the air. And the rain, I'm sure it's been rained on now over the last year. I think they're fine. If anything broke down voltage-wise, they're like 3 volts, 5 volts. Nothing's going to happen. Your fish will be safe, I think.
Okay, and the next question is a bit more technical. In regards to one-wire sensors, are they poled, or does the sensor itself transmit? And if it does transmit, poled. They are poled. Yeah. And how do you discover the sensors if you're polling them, if it doesn't know about them beforehand?
I tell you what, since it's a half technical question, I'm guessing the person asking it has some appreciation of electronics. It's a good question. That data sheet, there's a lot in it. I started looking at this going, how does it get, if you've got 10 of these on the one wire, how is it dealing with collisions if they all try to talk at the same time? And this is the same thing, you know, if you remember old, even before Ethernet, if you're that old, unfortunately I am, where you had IBM networks where you have collisions, token ring networks, and packets can collide on the network and they get retransmitted, and there's some randomization of time frames. It's magic to the uninitiated, but it works. The first time you get them, you hook them up to your Arduino, and one of the functions is, you know, discover, or I forget what it's called, and it just spits all the addresses out into the serial port. Then you have them all. And actually, what I did was, where is my one that's here? Am I on video, Jeff? I had one here. Where's it gone? I have it in front of me here. What I did on mine was, here's my single one, and I individually plugged them in one at a time. And when I got the address, I put a piece of tape on each one saying, whatever, this is 2E, whatever that is, 2E85, you know. And then I know when I put that one in the panel, okay, 2E85 is the panel temperature. So I don't quite know how it works. It's very detailed, but it's in the data sheet if you want to dig into it. It's very interesting how it works.
So the next question here is, if those sensors cost €1 and provide all this functionality, what would a €10 sensor get you?
Well, I think for more accuracy, obviously, I think accuracy is the big thing. For my application, I'm trying to measure the temperature differential across the underfloor heating manifold. The temperature going in should be more than the temperature coming out. I'm putting heat into the system. But the differential is only a degree, maybe 2 degrees. And these are probably not really good enough. There's a company called Sense Iron, and I hope I'm pronouncing it right. It's like Sense Iron, but it's Sense Iron or something. Swiss company, I think. And they make very nice sensors. I think they're 0.1 of a degree, much more accurate, but pricier. I think they're like a couple of euros for the raw sensor. So you'd get better accuracy, maybe better speed, but definitely accuracy is the one.
And the next question here is kind of related to that is, you're mentioning about the change in speed. Is there a limit to how fast you can pull them?
Yes, I think there is. I suppose I'm polling mine relatively slowly because I have a delay in my code, because when the values come up onto the LCD, I wanted to read them for a few seconds, so I have a delay. So I'm polling them, displaying the data. 3 seconds later, polling them. Okay. I'm not doing it that fast. I think it's probably buried in the code. The higher the resolution you request, the poll rate goes down.
Oh, of course,
yeah.
Okay, and I guess someone really wants to keep asking everyone, the second time they've asked this, what is your favorite Arduino project?
Me?
Yeah.
Well, I tell you, this one is, I've been tinkering with things. I have a Dewey. What Declan showed you and what I've showed you on mine is an Uno. It's the basic Arduino. There's one up from that is a Mega, which is a bigger version of it, more I/O. And then there's one up from that called a Dewey, which has a more powerful processor and some better analog to digital converters. And I've messed around with the Dewey, trying to use it as a frequency or a function generator, because you can address the registers directly and do fancy trickery. But in terms of a permanent project, you make things and then you take them apart and you make something else with them. These two are probably the most permanent projects I've done. So I'm trying to think if I've done anything else permanent that's stood the test of time. I don't think so. These have a real application.
Yeah. Okay, I think that's all the questions that have come in. Someone just commented saying that they also use the Sir Iron temperature sensors and they find them very good.
Yeah, good, but pricey. But you get what you pay for, I mean, it's fair enough. You want an accurate sensor, you have to pay more.
All right, thanks for coming along this morning, Gary.
Yep, thanks a lot.
So we have me on the screen again. So I'm going to give you the delight of watching my my project slideshow, another opportunity, while I set up our next speaker, which is Robert, who's going to be talking about his giant development kit. So give me about a minute while I set up the video call. And welcome back, everybody. A slight bit of technical difficulty getting someone on the phone, but we will come back to Rob's talk after Trina's, and we'll jump into Trina, who's going to give you, a snapshot of all our different projects over the course of her career as a TOG member. I guess I'm going to call it that. And we will change the screen here to Tree now and turn on desktop audio so everyone can hear her, and then I'll let Trina take it away there.
All right, rocking stuff. So I'm going to just talk about some of the things that I've been involved in that have an Arduino in them for a talk in 2021 about stuff that is a lot older than 2021. So at tog_Dublin, we very kindly Twitter knitted the Twitter handle for the Hackerspace, so feel free to tweet us more often. Okay, so first up, the Twitter knitter is an absolutely deadly piece of equipment. Let me see. Can you see my mouse? I hope you can. Brilliant. All right, so we made this for Dublin Mini Maker Faire in 2013, and for something that's not meant to be a permanent project, it is still hanging around in the space, and any minute now we're going to come in and dismantle it. But it's been a while. So myself and Becky, Tangent Monger, you can find the code for the GitHub for the Twitter knitter itself all the way here. There's an old blog post. It's not really current, but if it's still up, you can find more information and photographs. So the Twitter knitter is a knitting machine, simple as. On top, you will see a knockoff Arduino. They're not knockoffs; they're replicas. It's how it's intended to be. And what you can see here hanging from it is weights and some knitting. So there's a computer to tell it what to do, happy days, and this is the current Hackerspace. So some of the next photographs will be slightly older. So if you're not familiar with knitting machines, you move this carriage back and forth and knitting comes out and down. They get tangled up a little bit easy if you're not careful, but on the whole, they're fantastic and they'll do color changing for you. So this knitting machine is probably from the 70s. Was originally driven by punch cards. It turns out I bought the last punch cards in Dublin for this project back in 2012, 2013. And we were bored of punch cards. Like, you can crack punch cards up yourself, like just sitting there very carefully punching things, but it's a pain. You don't want to do it. So we basically took the entire plastic housing off and replaced it with this Arduino, 24 model airplane servos. So 4 belong to Rob, 20 belong to myself and Becky. 24 laser cut acrylic shapes. So I ran these up on the laser cutter out in DCU at the time. And what happens is the servos are tied to these with string. They're all mounted on a lovely wooden bracket that we put together. And that's screwed onto the area where the punch cards were. And so we're not actually replacing the punch card mechanism, we're replacing the punch card. So these little plastic bits lift up or down according to whether they need to be down, emulating paper, or up, emulating a hole in the punch card. And so there's 12 servos in the front, 12 on the back. And how knitting machines generally work is there's 24 repeating patterns just across the width of your knitting. And so we just effectively went, yeah, that's grand. We're going to emulate the punch card. So lines of color changing instructions come in. You knit across. You can just see in the corner here. These are like analog memory wheels. So as it goes past, it picks up from this row what the pixels are supposed to be, and it remembers them for the next row and picks up on the opposite side. It's got another set of things. Now, every single time it goes past, it triggers this micro switch. So there's a little micro switch here. So the Arduino needs to know when it's moved on to the next row. So hits the micro switch. The micro switch tells the Arduino, hey, send me the next line. Takes about 2 to 5 seconds for all the pins to change. And then you can go and knit your next row. Now, what sometimes happens was we had pins that decided to get stuck. So you would just end up with these stripes all the way down along. So this was for back when Dublin Maker was called Dublin Mini Maker Faire. So that's what we have in traditional Hello World. Let's see, can I get a video of this thing in action? I have no idea how to embed a YouTube video. Give me a second. we're going to copy that link into, I don't know, can you show a YouTube video, Jeff? This will just
Yeah,
show
if
how much
you
effort
do you want
I
to send
put
me
in.
the link in the chat message, and I can pull up YouTube. No problem.
Perfect. Thank you very much. Apologies for this, folks. This is why I never prepare things for the last minute. I have a rubber elbow. If you ever need me to speak, the lads have discovered that I will do it for them. So the link is there for you, Jeff.
Perfect. Let me just open link in a new tab. Okay, and let me somehow manage to show Trina and the video at the same time.
I'm just helping you show up.
Let me turn down the sound a bit. Okay, the video is blank.
All right, rocking. So what you're just going to see here is every time the carriage goes past, all the little pins go up and down. And then you pick up that row of knitting, and then when you hit the micro switch, when you go back, you see the little rows of pins change again. And if you listen very carefully in the background to the original YouTube video, you can hear me explain.
Yeah, because
I don't really have the sound on for the video because it's a bit
That's okay.
live event noise. Ah!
Deadly. Anyway, so you can rewatch this as much as you like. It's 17 seconds. You can play it on loop. Very soothing. Okay. Now, one of the other things that we did recently enough was back.
Undo.
What page am I on? All right, the protein knitter. So Science Hack Day 2019. So you'll find a lot of my projects are either involved with Dublin Maker or Science Hack Day because I'm terrible at finishing things on my own, but I'm much better at finishing things with friends. So Science Hack Day 2019, running the Hackerspace, we were like, all right, what are we going to do? And one of the guys, Alan Rice, you can find his Twitter handle here, generally tries to avoid doing projects. So I said, finally, after many years, I'm going to rope into him. So we took the Twitter knitter, updated some of the Python libraries from the GitHub, and actually, instead of printing tweets, we decided to print out mRNA and protein. So currently very much in vogue. RNA is the instructions that your cell gives to create protein. So first we printed out all of these DNA, so A double pairs of T, C double pairs of G double pairs of C, and we were just trying to figure out if we could get it working. This, by the way, stripe, is the error. I've run out of buffer. So that was good crack. Nice little Science Hack Day project. Twitter Nerd's back up and running, but someday we will dismantle them because it's not meant to be a permanent project. Plus, I want 10 of my little airplane servos back. Anyway, so the next project that I'm going to talk about is Fabric Cadaver. So on the left, you can see the prototype. So Science Hack Day Dublin 2013. The unofficial hashtag is never again, which means I've gone to almost all of them ever since. So what I really wanted to do was build a sort of soft body that you could take all the parts out and put them back on, and it would light up if in their correct location. So at the actual Science Hack Day Dublin, we just put it together and we're like, hey, this works. It's really cool, fantastic demo, pulling all the intestines out like a zombie. And then for Dublin Maker 2014, we decided to pull a hell of a lot of late nights. I'm like, oh, me and Jeff just getting high on solder fumes in the old space. And actually have something that would light up if you put the right organs in the correct place. So it's a group project. So the Tog Craft Group, we used to meet on Tuesdays. Now I think we meet on Discord. Declan will have all the details if you go bug him on Twitter because I'm a bit out of touch now that I live in Limerick. So everyone in the craft group put together different organs. We've got small intestines, we've got long intestines, we've got large intestines. They're not long, the long ones and the small ones. Beautifully embroidered hearts. You can actually see coronary veins going across them. And that was fine. Everyone brought their organs in appropriately shaped and all different random colors. And myself and Jeff pulled a load of late nights actually putting resistors in. So you can see little magnetic snap fasteners on each of the organs. These were joined internally by a couple of different resistors, so you couldn't put the wrong one in the wrong place. So if you put the wrong one in the wrong place, the light wouldn't light up because the Arduino would go, whoa, that's not the resistance of a left lung. What do you like? And so Jeff did a lot of the Arduino and, like, as I said, very much late night soldering. So on the back of the backing quilt, we've used buttons to actually stabilize the connections, because we knew at Dublin Maker people would just be horsing the organs off. In fact, like, it's just guaranteed, if you're going to show your thing to the public and people are going to be able to touch it, make sure you make it robust. Now, it doesn't have to be that robust, because the back of it is just wires, they're soldered into place. Up at the very top is an Arduino Mega, because you know what, multiplexing life is short. And that's just sewn into a zippered pocket up the top. It can run on battery, but generally we just ran power to it. So then it was ready for road, all plugged in. Someone took the right lung out to show a point, so it's no longer connected to the magnetic snaps. The lights come on for each neatly labeled bit of body. At one point, we had a child skipping rope with it, with the small intestine, because it's quite long. And it is still hanging in tog, or at least it periodically gets hung up in tog, but it's not usually plugged in because people don't realize it's an interactive piece. But that was great crack, absolutely fantastic. Highly recommend getting a huge gang together and building things. So, speaking of getting a huge gang together and building things, we have Science Hack Day Dublin 2016. Never again. Okay. And so what we wanted to do was build a sensor for if someone cycled too close to you. So I had just moved to Limerick. I just discovered that there is no such thing as a cycle lane in Limerick, just like there's no cycle lanes in Dublin. And I was cycling past a roundabout that's pretty busy, and I tend to just take up space instead. So I don't always cycle into the left. If I think if it's dangerous, I will cycle more into the middle of the lane to make it harder for people to pass me dangerously, because I deserve to be on the road. So what we wanted to do was see what we could do to, like, alert users, because apparently a fat woman on a bicycle wearing a yellow vest isn't enough. What else could we do? So we got these box, a couple of ultrasonic sensors, and what's difficult to see, and I don't have a video of this, which someone will have somewhere, there's a load of LEDs in the shape of an exclamation mark on the back of the vest. So promise you there is an Arduino on the inside of this. There's just ultrasonic sensors, really easy to get your hands on. As you get closer to them, it sends back a different signal, and you can detect up to like 3 meters different distance. So we were trying to set it up such that if you were far away, nothing exciting happens. If you got to within 2 meters, the vest would start to blink. If you got within 1 meter, it would blink rapidly. And if you got any closer, you were just, that was the end of that. And so we have a lovely laser cut box, because by then Tog had its own laser cutter, the laser saw, which is great crack. And then we won a prize. I don't know if it was People's Choice Award or just a well done for not getting cyclists killed award. But you can just about make out the LEDs. So I went home at one point because I just can't overnight, and I came back and I had left some poor lad soldering all of the pins into the jacket, because it wasn't intended to be worn on a regular basis. You can kind of get away with solder on things, even in textiles, if they're not going to be worn regularly or roughly. So same way we soldered everything on the back of that quilt. Naturally, it did stop working moments before the demo. Like, literally, we had the code working perfectly. It was time to submit. We made one last change. Never make one last change at Science Hack Day. If you think you've got it working, step away. Get a slice of cold pizza. It's done. So, in summary, you can do anything you want with servos, solders, some fabric, and friends. I highly recommend group projects because there is a little bit of guilt to make you actually do the work. I have dozens of unfinished personal Arduino projects, but the ones that I've done with friends have usually gotten finished, which is fantastic. Feel free to solder things, and like if you're doing e-textile work, if it's a quilt hanging up on a wall, solder it. Doesn't matter, doesn't have to be all soft e-threads. Punch cards are way harder to buy than model airplane servos, and if in doubt, use a Mega. So the Arduino, the Twitter knitter has an Arduino Mega in it, and the quilt has an Arduino Mega in it, because we're not multiplexing at 2 o'clock in the morning, lads, which would be well. So yeah, so as I said, find friends, build Arduino projects. It's tremendous fun. And with that, I think blank slide.
Suddenly appear on the screen now. And if Tree, if you want to stop presenting So you might have a bit of bandwidth for your video, because unfortunately at points you kind of froze in parts of it.
I'm wired all the way to the exchange. Oh wait, the modem's not blinking. Oh, that's not good. Anyway.
Oh well. So we have some questions here that have come in on the chat line. First, your projects seem to be a fusion of skills. How do you get people to work together?
You find people, you kind of get them a bit interested in the idea. So the Twitter knitter, like I love knitting machines, always loved them. Paul actually brought it into the space and repaired it, and Becky was like, I want to make that electronic. And she's got the electronic skills, and I'm kind of better with like cutting shapes and assembling things. So between the two of us, we got that together. For the fabric cadaver, you can kind of portion out to who's good at what. Like I'm pretty handy with sewing machines. The gang at the craft night are fantastic. Some stuff was hand embroidered, some stuff was just machine sewn. Woo! And then you find people who just want to help work on you. So Jeff is always, if you're looking for someone to help you with an Arduino project, I can highly recommend. His elbow is just as rubbery as mine. And you just ask people. And Science Hack Day is a brilliant one. So whenever that happens again, never again.
Maybe you can tell our viewers what it is.
Oh, it's a 36-hour hackathon. So you turn up at 8 o'clock on Saturday morning and you get yourself some pastries and some coffee, and people pitch little projects that they're going to run throughout the day. And people are free to join those projects to help out or move between the projects during the day and stuff like that. So people have built all sorts of wild things like Irish dancing shoes that operate as like a theremin. They make different noise when you dance. Fabric Cadaver was great fun. I'm kind of like, the guys worked on a robotic arm at one point during one of the last hack days. Bubble makers, all sorts of just like someone wants to build something. Becky tried to build an enclosure for the saddest lemon tree that would mimic the weather in California by pulling sensors in California and actually having fans and heaters in the little enclosure here. So it's just this great idea, and you don't have to be good at anything in particular. Like you can help out if you know enough about something. You can help out, or you can learn. So the fabric cadaver we did at Science Hack Day, I ended up with a bunch of business students who turned up going, "Hey, what's this thing about?" And I'm like, "Oh well, you know, I'm planning on doing this really soft thing where it's just going to be." And they're like, "Oh well, we'd love to learn how to use a knitting machine or sewing machine." So we just sat down, learned how to use a sewing machine, and put the whole thing together with people who had never touched a sewing machine before in their lives. And it's just kind of great. And there's loads of cold pizza, and we have a mascot dinosaur now these days. And you get prizes for, not quite for participation, but very close to prizes for trying hard. And there's like people try, it's fantastic. Look it up, Science Hack Day Dublin. As a SHD Dublin, is the Twitter handle. Someone will put it into the chat, Jeff. And that's tremendous fun. And that's always been a place where I've found great collaborators, because things like the bicycle, at another one we tried to build gloves that would allow you to, you put little patches on, and there was an Arduino lily pad on the back, and you would touch different parts of your hand so you could text from your pocket. You know, by just touching.
Very elite hacker sort of vibe going on there.
Oh, yeah. Like, I don't want to see. I like, your fingers are cold in the winter and typing on your phone, whereas now you can leave your hands in your pocket. Just type away. So like that was great fun, because again we found people who, like people who were designers who just wanted to make it look beautiful, people who were coders who were like, yeah, just tell me what the interface is and I'll make it work. And people who like to sew, and we made like dozens of prototypes of really bad gloves that day. It was great fun.
Okay, and the question that seems to be asked of each of our speakers: what's your favorite Arduino project?
That I've been involved in personally, it's a tough one. I'm kind of leaning towards the fabric cadaver because I just thought that was ridiculously good fun. And I think it turned out, like, I love the Twitter knitter, but it's been around so long that everyone's like, make it work again. And then like other people's Arduino projects are great fun. I love, I know Robert's going to talk. You better talk. Get online, Robert. about his giant Arduino set. I love that. I just love the whole concept behind it. And yeah, like I've personal Arduino projects that have never finished, so they can't be my favorites yet.
Okay, well, thanks for joining us. I guess it's this afternoon at this stage. Well, thanks for joining us, and we hope to see you on another live stream event sometime soon.
No doubt. We'll talk to you then.
Thank you. Bye. So, thanks very much, Trina. We are going to switch over to the great slideshow. I know you've all been enjoying it now while I set up the video call with Robert. So back to the slideshow. I'll be back in about 2 minutes. And welcome back. I know you're slightly disappointed there that you can't see those great images of my projects, but let me switch our screen and we're going to go live to Robert. I'm going to turn on his audio, and Robert, you are now live.
Hi everybody, or hello. So today I'm going to show you the giant Arduino starter kit project that I built. It's probably 8 to 10 years old now, I think, at this point. So basically the idea is to take a normal Arduino and just make it 10 times bigger. So what I did, because the project was open source, I was able to take the PCB files, the Gerber files, and I used those to create this artwork. So this is just a piece of MDF, and I took each of the layers, color corrected the pieces, and had a large A1 photo printed. I cut out all of the wood by hand. I drilled all the holes by hand. We didn't have a laser cutter at the time, and we didn't really have a working 3D printer. I think we had the original MakerBot Cupcake, but it didn't really work, so I ended up making all the pieces by hand. So these uprights here are wood with copper tubing that fits inside them. I then fabricated Here's the electrolytic capacitor that would go in the Arduino, and so that can then. So this uses a spray can lid and MDF and polystyrene to make. I forgot what that's called. Crystal. So that was the one that was there. I also made the Meenagh chip. This is polystyrene with aluminium metal, like the dip legs. So the kit. So basically, this is effectively an Arduino shield that has just been scaled up. On the back, you can see how the Arduino connects in. So I designed up a PCB here that has the regular sized Arduino that connects in like so. This has protection diodes to stop. So it is a fully working Arduino. So I use the protection diodes to stop the Arduino from being burnt out if somebody shorted the 5-volt rail to one of the GPIO pins. I had made a giant breadboard. So here's the original breadboard design there. And inside there, there's copper tube with braid between it, the electric conductors. So it was all working. I did resin casting and mold making to make giant LEDs. So this was the original mold that I made out of plaster of Paris. And I forgot one of my LEDs. I have one of my newer LEDs here, so you can see the giant LED there. I'm not sure how much more details go in. I think the process of not having a rapid prototyping tools was actually very useful for. I learned so much more by not having access to a 3D printer or laser cutter at the time. Lots of hand fabrication, experimenting with different materials, wood and metal, glues, resins, and painting. I don't think I would have covered if I hadn't, by not having the laser cutter and the 3D printer at the time. I think that's probably it. It is a bit more of a project you need to see in person. I don't know if there's any questions, Jeffrey?
Yeah, I'll just turn on my mic and figure out how to turn on myself. There we go. I'm back in shot here now. And I have my mic turned on. And then, well, we can see Robert's face. It's
my long hair?
It's all going well. Return to the long hair. I think the first time I met you, you had long hair. That must have been, I won't mention how long ago, but it wasn't recent. So, some questions coming in about how heavy is this thing? It looks like it's all wood and metal.
It's. I never actually weighed it. Actually, so you well, you have your standard bag weight. So I think it's at least 10 kilos. It's probably closer to 25 kilos when you're adding all the giant LEDs and other bits and pieces. So your standard bag with Aer Lingus is about 20 kilos. So I would have the project and then some clothes. So for taking these projects to the likes of Maker Faire, the UK Maker Faire, was one of this project was originally designed to be presented at, and then put in a maker.
So as you said, it's a functioning development kit. One of our members here, Gary, wants to know: did you get Blink working?
Yeah, because it's yes, of course, it's the easiest one to show.
And do you have any resistors?
If I go off screen and grab one.
Okay.
Yeah, so there's the giants.
And is that like 5 ohms or something, or
Well, as it's written on it, it's 10K.
10K?
So it's basically a plaster of Paris body, and this is the insides.
Oh yeah.
So it's just a half watt LED or something, or half watt resistor inside it. And these were the original giant LEDs I had made. So these have a a copper tube, and then they can go into that. And then there's jumper wires I also make.
Oh wow, it really is everything in a development kit.
Yeah. So
And you even have them color coded. Yeah.
I had LEDs and resistors. I had an LDR, and then a potentiometer. So some of the basic things you would have had in a development kit.
It looks like you have inspired someone here to make a 10 times scale temperature sensor. Gary, one of our previous speakers.
I'd probably suggest using the 3D printer to do it. Definitely easier.
Yeah. And Howard wants to know, have you used what he's calling the Super Arduino for many projects?
No, it was only ever a thing to be shown at maker fairs. It's not practical. When I made a 10 times scale model because that meant the maths was easier.
Like the metric
But
system.
it's not practical at all. I had to buy the biggest suitcase I could find the weekend before the traveling. The first time we made it when we went to New York, I actually had to cut the board in half.
Yeah.
Basically, I already have. Not practical at all. I wouldn't recommend.
Okay. The next question here from Gary is, it looks like it's more of a shield than an actual Arduino. Did you consider making the Arduino development board itself from scratch?
I can't remember if it's, yeah, like it definitely is a shield. I can't remember if I thought about doing a full size scale model. Maybe you would do 5 times. So it'd be about, the size of a A4 sheet.
Okay. Alright, let me just read the chat here. There's some comments on people liking your long hair. That's always nice to hear.
This is my lockdown look.
Okay. And practical. Okay, it's nothing got to do with it. It's not very practical. Okay. All right, and I guess the question people have been asking each one of our speakers: what's your favorite Arduino projects? Have you used them in many projects apart from this?
Yeah, they're a great stop, middle of the road device. So you have PICs and AT-Tinys that if you have just something very, very small, simple blinking LED, you would use those. If you need much more computing power or connectivity, you might use a Raspberry Pi. I like the Arduinos is a very diverse platform. The ones that I've done some other work with are the wearable, integrating for electronic fashion, integrating electronics into clothing. So probably the lily pads and the flora type uses. I think they're a good example of using the Arduino.
Oh, okay.
Uno style form factor.
Yeah, so it's especially small ones for wearable electronics, as you said. And so when you compare Arduinos to like other programming or other kind of ecosystems, how do they compare with, say, this and other more ones that are designed for the pro market, like your PICs or your your ARM processors?
Yeah, I haven't really used a huge amount of other ones. I used a number of my other projects that I created. I've used the embed programming environment, and like that had an online compiler. That was kind of interesting, but it was significantly faster and it had a lot more memory, a lot more processing. I haven't used any of the newer Arduino, the ARM-based Arduinos, too much. We had done some work with the Intel Galileos as well. They also could work with the Arduino development environment. So you could start off with an AT tiny project and then realize that's not really good enough. I'll maybe use an app mega or go into a duo and then maybe even bring it up. I think there's probably a kind of compiler IDE front end, like the Shield compatibles. Yeah.
Okay. Would you like to mention anything else, Robert? Maybe you've showcased a lot of giant LEDs. Do you want to tell people a bit about that?
Well, so the original giant LED used the plaster of Paris hand molded, and then this kind of putty. And so I would bring this giant LED because it's relatively portable and not particularly. It's relatively portable, and I would bring it to maker fairs and other events of the maker, and almost every time somebody asked me, do I sell them? And I didn't until about 3 years ago. So I went through a process, recorded a number of videos of making a much more refined version. There's brass rod inside the legs, there's surface mount LEDs inside here. So I then make and sell these.
And where would people be able to find out about that?
I sell through the Tindy platform. I also have my own YouTube channel that I haven't updated in almost a year, where I have a playlist where I show how I designed and made the different types of molds. Yep.
Okay, I think that's all the questions I can see here on the chat. Thanks for joining us this afternoon, Robert, and sharing your giant development kit.
Thank you.
Thank you. So it's just back to me on screen again. I know in our running order we had myself due to give a LoRa WAN talk, but that everything unfortunately got in the way. So I don't have a detailed LoRa WAN talk for you now, but I'm just going to give you a slight peek at LoRa WAN and the project that I'm building, and then at Tog's next streaming event, I'm sure that I will give a talk in more detail. So I'm going to switch using the fancy software and switch to my tablet. There we go, it's on screen now, where you see me and then my tablet there. Just give you a quick snapshot about what LoRa WAN is and what I will go into detail in Tog's next live stream event here. It's a low-powered, relatively long-range communication system built for microcontrollers. So you have your Wi-Fi, which is relatively short range. I guess if you wanted to go further than Wi-Fi, you're looking at maybe cellular networks. But the downside of cellular networks is the battery power consumption. So it's very hard to have devices that you can put a battery in and leave for 5 years on cellular networks. It'll just end up eating up the battery too much, and you won't get that long lifespan comparative on your device. And you can't really have environmental sensors or different applications in the wild where they mightn't have power, or you mightn't want to service them the whole time. So what I have here on my board here is I have a LoRa Shield made by, I think the company is called Dragon here, and it's transmitting to what's known as a LoRa gateway. So you have these gateways to accept LoRa messages, And then I am using at the moment a community network. So this is where people put networks in their own homes. They put gateways in their own homes, and you can freely use the gateway to send and receive your messages. So I've done a bit of testing. So from my house, I can get up to about, say, the last time I tested was about just under 2 kilometers away. Using this little antenna. You bear in mind that I'm using an indoor gateway, and it's on the ground floor of my house. Recently, a friend of mine gave me a new homemade antenna, which will drastically increase the range of my gateway. So the plan is to move my indoor gateway up to the attic and use this much better antenna, which should then give me a much further range for devices around for me. So yeah, to give you a quick other preview, I'm going to jump to showing my screen, and here's the platform here. Of course, I'm showing you all my ID numbers that I shouldn't, and I'll end up just deleting this project here because I've just shared my unique device ID number, which I shouldn't have. But we will have a quick look at the data that's coming in. And when we click live, last seen 55 seconds ago, always a demo, and it doesn't really want to show live data while we're testing. Anyway, seeing as there we go, we're starting to hear we're starting to get messages there, and if I scroll down, there's my payload. It's sitting out. I have a little temperature sensor there, seeing as we're all talking about temperature sensors during today's talks. So we have a relative humidity of 51 there, 51%, and a temperature 19 degrees there from the unit. But anyway, that was just a snapshot as to what LoRaWAN is. Apologies again for not having the talk fully prepared, but things get in the way and coming up with all the graphics, and so for today's live stream kind of got in the way. But you'll see a LoRaWAN talk in a few weeks when TOG does its next live stream event. So once again, I want to thank all our speakers for coming along today, and for all our TOG members who showed off the projects that they've done over the last few years. If you'd like to speak at a TOG live stream event, we have one planned for next month. We usually do 3 speakers on the night, so you can come along, talk about your project. It's a great environment to showcase your knowledge, and also trying to get some feedback on a project that you might be working on. So if you'd like to get involved, drop an email to info@tog.ie. And if you'd like to get involved in the virtual events that TOG showcases, you can find all about them on our main website, tog.ie. And the final thing I will say is, if you are very hungry for even more Arduino contents, the main Arduino project are doing a special live streaming event themselves that starts at 3 p.m. Irish time, and you'll find that on arduino.cc. So again, thank you all for coming. Hit that subscribe button, and you will get notification for our next streaming event. Thank you. And everybody thought it was over, but I will skip in there because I just saw a message about Trina, who's insisting I talk about my favourite Arduino project, seeing as I have subjected everyone who has spoken here today. So I guess my favourite Arduino project is my bone conduction project. It is it uses bone conduction. It sends vibrations through your teeth, through your jawbone, and then into your inner ear. It uses an Arduino, it uses an Intel Galileo, mainly because I got lots of them free at the time, and it was a convenient, nice, easy board to use. And so I don't have any pictures. Let me quickly flick through. Oh, there you go. We have a great picture there. And I switch back to OBS and show myself on the screen, and boom. So yeah, this is the project that I guess got the most traction. And if you've been to a double maker, you probably have tried it out. It's a Arduino Galileo. They're designed in Dublin. Well, I guess we'll give it to Kildare, but designed out there in Kildare in Leixlip. It's an Irish design board made by Intel for the maker market. I have a USB sound card there for playing audio out through it. I have various temperature sensors and relays, and it plays music when you bite a metal rod. Find out more about the project. You can jump onto TOG's website and search for School Radio. And it has all the documentation there, and I'm sure if you come along to a double maker when we're allowed to have it in person, I'm sure you can try it out there. So I'll wrap it up again. Thanks all for coming, and we'll see you at the next event.